Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 6, 6.5, and we're looking at integration using partial fractions. Now, there isn't anything new in this lesson, but it is joining together quite a lot of different things that you should have learned through the course. We'll go straight into an example, and we'll do both parts separately. So, part 1, express 5x squared minus 8x plus 1 over 2x into x minus 1 squared in partial fractions. And then once we've got the answer to that, we'll be using that answer in order to find this integration. But we'll just look at part 1 first of all. Now, it's an atypical case. So I'll get you started and then let you try and finish the question. We've got a 2x term here, and we've got this quadratic term x minus 1 squared in the denominator. What that means is we need to try some constant over 2x, some constant over x minus 1, and also a separate constant over x minus 1 squared when we split it up into partial fractions. Okay, I'll let you and try and make your own way forwards from there. So pause the video and have a go at finishing this part, and then come back to me when you're ready. Okay, let's have a look at this. So standard method for these, we add these fractions together, and the common denominator will be 2x times x minus 1 squared, because x minus 1 goes into that. And then you just need to be careful with these terms in the numerator. So we'll have p times by x minus 1 squared. The x minus 1 squared would cancel to give us p over 2x. We'll have 2qx times by x minus 1. Now the 2x and one of the x minus 1s would cancel to give us q over x minus 1. And we'll have 2rx, and the 2x would cancel with the 2x to give us r over x minus 1 squared. Having done that, the easiest way with these questions is to at least start off with substitution. So we'll substitute x equals 0 in, because x equals 0 will make this middle term 0 and this final term 0. So putting x equals 0 into the numerator on the left-hand side gives us 0 minus 0 plus 1, which is just 1. Putting 0 in the right-hand side, as we said, these second two terms become 0. And all we have is p times by minus 1 squared. And minus 1 squared is plus 1. So straight away we know that p equals 1. We then substitute in x equals 1, because it'll make both of these two brackets equal to 0. So putting x equals 1 into the left-hand side gives us 5 minus 8 plus 1 for the numerator. And into the right-hand side, it gives us 0 plus 0, because both of these brackets will equal 0, plus 2 times by r. That means that 2r is equal to minus 2, and r equals minus 1. Now, to find the final constant, to find q, the easiest way to do it is normally to choose the highest power. So we'll look at the coefficient of x squared on both sides. On the left-hand side, we've got 5x squared. On the right-hand side, if we squared this bracket, we'd get x squared times by p, which is what we've got there. And then multiplying out these brackets, we're only interested in the x squared term. We get 2 times x times q, so we get 2qx squared there. And there are no x squared terms in the final term. That means that 5 is equal to p plus 2q. P we know is equal to 1 because we've already worked that out. So that means 5 is equal to 1 plus 2q. That means 2q is equal to 4 and q is equal to 2. So that's what we've done so far. We've worked out the constants p, q, and r, 1 minus 2 and 2. Now we just substitute those in. And that gets us this algebraic fraction can be rewritten as 1 over 2x plus 2 over x minus 1 minus 1 over x minus 1 squared. That's part 1 complete. Now, part 2 asks us to use this answer in order to work out the integral of the algebraic fraction between x equals 4 and x equals 9. And they've asked us to give us the answer in the form, the log of some constant, take away another constant. I'll let you have a go at working your way through all of that. So these three individual terms, you're going to have to integrate. The first two will be using ln x, but I'll let you have a go at making sense of all of that. So have a go at part 2, pause the video and come back to me again when you're ready. Okay, let's have a look. So rewriting this in terms of partial fractions, the integral becomes that. And then each of these 3 terms we need to integrate separately. So 1 over 2x, that becomes a half log x if we integrate it. If you differentiate that, you get a half times by 1 over x, which is what we want. Integrating this, again, as long as it's only x on the bottom and nothing more than that, we can normally use log. So the log of x minus 1 times by 2. And if we differentiated that, we get 2 times by 1 over x minus 1. So that is fine. And this one here, we've got x minus 1 to the power of minus 2. The power goes up to minus 1. And we just need to make sure that everything's okay with constants and pluses and minuses. So I would differentiate this and make sure you do get that for the answer. Differentiating this gives us minus 1 times by x minus 1 to the power of minus 2. Using the chain rule, we then have to differentiate x, but that just gives us 1. So it does give us minus 1 over x minus 1 squared when we differentiate that. Now we need to substitute in the limits 9 and 4. Substituting in 9 would give us this. Substituting in 4 would give us that. So that's what we've done so far. Now the rest of the question is really just tidying up the answer, but it does take quite a long time to tidy up this answer and get it in the form that they've asked for. So first of all, getting rid of all of the brackets, we've got a half log 9, we've got 2 log 8, 8 to the minus 1 is 1 over 8, we've got minus a half log 4, minus 2 log 3, and 3 to the power of minus 1 is a third. Now the next thing I'll do is combine these 2 terms together and these 2. And log 9, that half on the front, we can use the power rule for logs. So that will be the same as log 9 to the power of a half. And that means the square root of 9, which is 3. So that'll be helpful. And similar here, using the same rule, we've taken the 2 into the log to get the log of 8 squared there. We've taken the half into the log here to get log 4 to the half. And again, the square root of 4 we know. And we've taken the 2 into the log here to get log 3 squared. Now, 9 to the power of a half is 3, 8 squared is 64, the square root of 4 is 2, and 3 squared is 9. That's all we've done there. Now we're going to use log a plus log b is equal to the log of a times by b. So that equals the log of 3 times 64, using the addition rule for logarithms. And similarly here, we've got log 2 plus log 9, which is log 2 times 9, using the addition rule again. 3 times 64 is 192, 2 9s are 18, and I've combined these 2 fractions together to get minus 5 over 24. Now we're going to use the subtraction rule for logarithms. Log a minus log b is the log of a divided by b. So we'll have log 192 over 18, minus 5 over 24. And that simplifies to the log of 32 over 3, minus 5 over 24. And I think that is as simple as it gets. And that's also the answer written in the form that they asked for. Okay, if the degree of the numerator is greater than or equal to the degree of the denominator, it is necessary to begin these questions by dividing the numerator by the denominator using algebraic division. Now I'll have a look at an example to see what that actually means. So it's where you've got something like this. You've got f of x is equal to a quadratic over a quadratic. So the degrees are equal to each other. The numerator has degree 2, the denominator has degree 2. Now, if the degree of the numerator is either greater than or equal to, you need to carry out algebraic division first of all. And then we'll be able to write it in the form p plus q over x squared plus 2x plus 4. We'll do the 2 parts separately. Once we've done part 1, we then need to actually carry out the integration. But we'll worry about part 1 first of all. Now, to do this, you need to remember how to carry out algebraic division. You can either do that using long division, or you can use it using another method where you just work out what you need to multiply this by to get that and work out what the remainder is. Anyway, whatever method you use, I'll let you have a go at doing it yourself first. So pause the video, see if you can take this forwards, and then come back to me when you're ready. Okay, let's have a look at this. Now, if I was carrying out the division, then you've got the top is equal to the bottom, and you've got to work out what you need to times by. Now, in this case, there's very little you need to do. 1 times by x squared gives me the x squared that I want. So the quotient would be 1. I'm timesing by 1. And when I do 1 times 2x, I actually want 4x. So I need an extra 2x. That's why there's the 2x here in the remainder. 1 times 4 is 4. I actually want 6. And that's why there's the 2 here in the remainder. So 1 times by that plus this would give me that. And the reason for going to all of that trouble is we can now carry out this division. So if we divide both sides by x squared plus 2x plus 4, which is what we've got in the original algebraic fraction, then that is what we would get. These will cancel with each other. So x squared plus 2x plus 4 cancels with the x squared plus 2x plus 4 on the bottom. And we get 1 plus, and we've still got 2x plus 2. Divided by the x squared plus 2x plus 4. And that is in the form they've asked for. So p would equal 1, and that would be the quotient, and q would equal 2x plus 2. And that would be the remainder when we carry out the division. That's part 1 complete. Part 2 says, using this, hence find this integral. So I'll let you have a go at doing that. So you rewrite this in that form, and then you have to carry out the integration. Now there's a trick here when you have to integrate this second term to do with logs, but it's very easy to miss it. I'll let you have a go yourself first. So pause the video, see if you can do this, and then come back to me when you're ready. Okay, let's have a look. So rewriting the question, we'll have the integral of 1 plus 2x plus 2 over x squared plus 2x plus 4. Now 1 is easy to integrate, we'll just get x when we integrate that. But there's something really important that you need to notice about this algebraic fraction, and it is very easy to miss it, which is if we differentiate the denominator, we get the numerator. So if I differentiate x squared plus 2x plus 4, I get 2x plus 2. Now, if ever that is the case, so if you ever have the integral of the differential of a function over the function itself, when you integrate that, you will get log of whatever this function is. So it means when I integrate this, integrating the 1 gives me x. And when I integrate all of this, you can immediately write down the answer. It'll be the log of x squared plus 2x plus 4. And again, just quickly check that that makes sense. So if I differentiate this, differentiating the x gives me 1. Differentiating this, first of all, I differentiate the log. That'll give me 1 over x squared plus 2x plus 4. Then using the chain rule, I need to differentiate the x squared plus 2x plus 4. And that gives me the 2x plus 2 that I'll get on the top. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 83 and have a go at exercise 6E. Thank you very much for listening, and cheers.